Hi, Jan here. This is the third video in the Fantasy Map series, and today we are going to talk about ocean currents and precipitation. So let's start. We have the map as we had it last time, and I've also added lines for the 45 degrees latitudes. You will see why. And we use a simple wind map for this, as ocean currents are created by pressure, by rotation, by wind, and by density. We have two ocean currents that flow from the east to the west, and those are pushed by the winds that coming from the north and the south. The ocean currents split where they meet the landmass, and some of the water will flow back towards the east as a deep ocean currents. Now we have water that warmed during its journey from the east to the west on the equator, and when it splits, it will flow towards the poles. The wind will push the warm water after some time at around a 45 degree to 60 degree latitude towards the east again. Now you have ocean currents that goes from the west to the east blown by the wind, and it cools down on its path on the higher latitude. The temperature of ocean currents is always seen as relative to the water around it. So when you have the same temperature of water, one flowing towards the equator, it's cooler than the water at the equator, and when it's flowing down from the same spot to the poles, it's warmer than the other water near the poles. So now when the water splits, when it meets the land, you have one cool current flowing towards the equator and one warm current flowing towards the pole. Now you may understand why we have a high pressure area west of the landmass, and that is because the cold water that comes from the ocean currents. And the low pressure area east of the landmass has nothing to do with the ocean currents, what you could expect. It's actually created by the wind that is coming from the poles and from the equator. You have warm wind and cold wind that meet in the middle and is pushed towards the atmosphere, and therefore there is a low pressure area created. So let's fill in the other ocean currents. As you can see, some of the ocean currents can split up. They will always have cold currents flowing towards the equator and warm currents flowing towards the pole. You also have small ocean currents within pockets, for instance island chains, within inner seas, or within very large lakes, for instance, as you would see within the Mediterranean Sea. There's one more phenomenon I would like to talk about that is created by ocean currents, and that is called El Nino. El Nino is a phenomenon where warm water forms on the east coast of a landmass and cold water forms on the west coast of another landmass. This only is created when you have a large space between the two land masses. You have a lot of warm water on the east coast, which means you have warm air, you have larger vaporization, you have more moisture in the air, and therefore more rainfall. Also, nutrient-rich water is pulled out of the deep sea at the west coast of the other continent, which is then pushed by the air and the ocean currents towards the east coast of the other landmass. So you have coral reefs in the warm water and a lot of nutrient-rich water where a lot of plankton and other animals will live. The system breaks down every few years, and you will have then less warm water on the east coast and less cold water at the west coast, and a few years later you will have everything in a cycle starting again. Let's talk about precipitation. Warm air can hold more water than cold air. When warm air is moist and it cools down, droplets form within the air, which you can see as clouds in the sky. The colder the air gets, the more water droplets are created, and over time they form larger drops, and those larger drops become so heavy that they are going to fall down to the earth. There are three ways how rain is created. The first one is called rain relief, and that happens when air is pushed towards a mountain and cools down while it's going up the mountain. As we've learned, the air cools, droplets are formed. These droplets form drops which rain down. You always have one rainy side of a mountain and one dry side. The rainy side is the side where the wind blows on and loses all its moisture, and on the other side of the mountain you have dry air. Then we have frontal rain. Frontal rain is created at areas where we have warm air and we have cold air. So now we have a cold cloud and a warm cloud, and the warm cloud will rise above the cold cloud, and it will become colder, and therefore it cools down again. We have raindrops forming, and it's going to rain. And at least we have convectional rain. Convectional rain forms where it's warm. So you have moisture and warm air going within the air all the time. It cools slowly down while it goes towards the atmosphere, and by cooling, the clouds become bigger and bigger and bigger, and they form droplets and raindrops again and rain down. There's something you would expect at the equator or where the sun rays hit the earth the strongest. Let's look where we have a high precipitation during spring and during autumn. So at first we have convectional rain, and that forms on the equator where the sun shines the strongest. As we also have warm ocean currents, warm water will be at the coast, creating warm air at the coast, a lot of vaporization, and therefore a lot of rain falls at the coasts. What we also have is onshore winds. So at the equator we have the wind blowing from the east to the west, which means that on the east side you have a lot of rain that comes from the ocean. So now, as we know that, we can around the equator create larger rain areas. Now we can look at the warm currents on our world map, and everywhere where we have warm currents we have coastal rain. You will also have rainfall on the 60 degrees latitude or the subpolar low due to the warm and the cold winds that meet there, and that is the place where taiga or boreal forest is often formed. Then we also have orthographic lift at places where you have mountains, so there must be a wind that blows towards the mountain to have rainfall on one side of the mountain. When you have a wind that blows along the mountains but not towards the mountain, you won't have a lot of rainfall at those mountains. You can also have rainfall within deserts and within steppes on mountainsides, and the largest rainfall will be created at places where you have all things meet. So you have orthographic lift, you have onshore winds, and you have warm water. What you have to keep in mind is that within large land masses you won't have a lot of rainfall, and that you don't have a lot of change in rainfall on the coast. And that's it for today. Thank you for watching. I hope you have learned something, and I hope you have enjoyed it, and we see us in the next one.